So this is just a reminder of when I talk about factor label, when we work problems now and throughout the, gosh, are we on like week 3? The next 13 weeks, we're going to have to work problems, making sure you always have units. And then we're going to remember that you should never have a unit like, you know, good units of densities are grams per milliliter. You should never have X grams per milliliter over 1, okay? We'll be talking more about that, but it should be like X grams per 1 milliliter. It's like unpacking that. It should never be like this. It should be like this. So let's work one more problem. It's the loon problem. We didn't do this on Friday, I don't think, did we? Have this in your notes? So this is just using how fast a loon is flying as a physical property of that loon. So I kind of changed it up. We're going to get to the problem that you guys have. But let's just say that the loon is flying at 14 meters per second. That's pretty darn fast. Okay? And then your question could be, how long will it take in seconds for the loon to fly 28 meters? What do you think? If it can fly 14 meters in 1 second, if you want to go twice as far, how many seconds? 2 seconds. So what you guys just did basically was what we're going to do is a factor label problem. So you want to fly 28 meters, not 14 meters. You know that in 1 second it will fly 14 meters. Okay. Now, as I set it up like this, my meters cancel. I'm left with units of seconds, which is exactly what I want to be left with. Okay? The first term I put was how far I want to go. The next term I used was how fast is it going. In 1 second, it can go 14 meters. So it takes 2 seconds to go 28 meters. So that one seemed a little straightforward. So what the real problem is it looks like this. We're working with the same loon. It's a physical property. How fast is it going? 14 meters per second. In this case, we don't want to necessarily know 28 meters, but we want to know 5.00 kilometers. So we're going to let it go a little bit farther. It's going to take longer than 2 seconds? Yes. How much longer? Well, let's do the math. The other thing about this problem is we don't want the answer, the time in seconds, we want the time in minutes. Okay, so to work this, we're going to use the factor label method. One of the things I encourage students to do is to pull out the physical properties. In this case, how fast is the loon flying? 14 meters per 1 second. We could flip that if we needed to. It's the same physical speed for the loon. In 1 second, it will fly 14 meters, or we could flatten it out. For this particular loon, this particular day, 1 second is equal to 14 meters with regard to how fast it can fly. So here we go. So right off the bat, though, my velocity is in meters per second, and my distance is kilometers, so I'm going to have to fix that. So we're going to have to go from that 5.00 kilometers to meters. And I know you guys are used to just moving the decimal place, okay? But you have to do, like I'm hoping your homework that you handed in just now does. You have to show that conversion. Of course, the kilometer meter thing, you're going to have to memorize that. Kilo means 1,000 times the base unit. So we know that this is an exact relationship. 1 kilometer is exactly equal to 1,000 meters. Well, once we have meter thing down, then we can go ahead and insert how fast the loon is flying. So once we go ahead and kind of do our front-end conversion from kilometers to meters, now we can stick in the whole, we want meters to cancel, so that's what's going to go on the bottom. And we want to be left with units of time, seconds, that's going to go on the top. So we're not quite done. What's the relationship between seconds and minutes?
60 seconds is equal to 1 minute.
Yes, 60 seconds is equal to 1 minute. Is that exact? Yep, I think so. So we're gonna use that as a ratio to get from seconds to minutes. So here we go. The first term is gonna be that 5.00 kilometers over 1. So 1 kilometers to cancel, want to be left with meters with the next term. What does it look like?
1 kilometer on the bottom, 1,000 meters on the top.
Very good. 1 kilometer in the bottom, 1,000 meters in the top. Perfect. Units of kilometers will cancel. I have units of meters. Now I'm ready to use a velocity to get to seconds. So what does that look like?
14 meters on the bottom, 1 second on top.
Yep, 14 meters on the bottom, 1 second on top. Very good. Perfect. And we're almost done. Ready to use this to go ahead and get units of seconds to cancel, be left with units of minutes. So,
60 seconds on bottom.
yep, 60 seconds on the bottom, 1 minute on the top. Perfect. So now unit-wise are the units that factor or cancel. Kilometers cancel, meters cancel, seconds cancel, and we're left with units of minutes, which is perfect. Now let's put check marks where we need to round according to this number. How about the 5.00 kilometers that we start with? How many people think there's uncertainty in that? I do. How many sig figs?
With all of these problems, are we rounding to the sig figs, right?
If we're multiplying like this, we are. If we're adding or subtracting, we're according to decimals or ones places. Yep. So how many sig figs, since we're multiplying, is 5.00?
3.
3. Perfect. Okay. So how about this with the whole metric system? Do we have to round according to any of those digits? Nope. Ah. How about how fast the loon's flying? How many people think that there's uncertainty there in the 14 meters per second? Why do you think there's uncertainty in there? There is.
Because it might not fly 14 meters every second.
Yeah, that's like an average. It's an approximate. It might not be right at 14. Yep. So there is uncertainty there. Now, anytime you have something like 14 meters per second, we unpack that to basically kind of make the, how do I say this? Approximately 14 meters per exactly 1 second. That's how I kind of chant it in my mind. That's how we've unpacked it. So approximately 14 meters in exactly 1 second. So how many sig figs in 14? 2. Yep. Okay. How about this last one? Do we have to round according to?
It's exact.
It's exact. Yep. So I'm thinking 2. Is this what you guys got? 6.0 minutes? Yes. My answer key is right. It's Monday. Any questions about that?
Your times, if you take 5.00 times, well, I guess you don't really have to do times, do you? Since it's 5, because if you do over 1,
Wouldn't it be 5?
that's going to be
then?
5.
So kind of like what you're saying. Oh, I see what you're
I'm
saying.
just asking, like, if,
In your calculator?
yeah, if you want us to do over 1, so then you're like,
Yeah. Yeah, I
timesing
probably would.
each.
I would usually put that first term over 1 so I show that my kilometers in the numerator in the
Yeah, so
top.
then when you type it into the calculator, it's just 5.00
Yep.
times.
And then my ones I usually don't include.
Because it's just 1.
Yeah, it's just 1. And then in the bottom, what do I have? 14 and 60?
Okay.
And then just more, and then you divide both.
Mm-hmm. Yep.
I just want to make sure, I got the right answer, I just want to make sure I was doing it right.
I
Either
did
there.
it.
Because if I
Yeah.
messed up on the test on the calculator.
Right. And the good thing about, as far as your test or your homework goes, the good thing about showing all of your work and working it this way is you've communicated how you work it. So like if your finger slips or whatever, you know, you're almost there. So you almost get full credit even if you get the wrong answer at that point. So it's kind of nice. Okay? Well, we already did the homework, and we're going to skip the last example with regard to energy for now.
It would have been 5.95.
So on to the next part, hopefully. Well, that's a good sign. All right. So factor label method, here to stay. We're going to take it up a notch. Okay, I'll show you what I mean. So, for instance, and I think I'll go ahead and draw it on the board. It's on the next slide too, but just bear with me. Let's say you have 1 square yard. So I have 1 yard by 1 yard. So how do I get the area? Yep, length times width. So I got 1 yard times 1 yard. So I take my number, 1 times 1 is 1, and I take my units of yards times yards is, what's those units? Yards twice is yards squared. Yeah. Cool. Well, we're going to break it up, and I'm going to break this into thirds. So there's what? 3 feet in each yard, right? So the question here then is simply, for this box, so I'm going to do area again, is length times width. But in terms of feet, how many feet is 1 yard? 3. So does this make sense? We got 3 feet times 3 feet. So 3 times 3 is what? 9 feet squared. Okay. So that looks like this. So what 1 square yard is equal to 9 square feet. And somehow we need to get there from our kind of 1 to 3 relationship. 1 yard is equal to 3 feet. So I'm going to show you how to kind of scale that up, kind of work with that in a factor label way. So 1 yard is 3 feet, so I bet you buy this. We go ahead and simplify both sides, and we have 9 square feet is equal to 1 square yard. But let's just say we were trying to kind of, it's almost like belaboring the problem. We're going to apply the factor label method and do the same thing. So in this case, the thing I want to convert is 1 yard squared. I want to get to, instead of units of yards squared, I want to get to units of feet squared. And I want to come up with the number 9, basically. Okay? So if we go ahead and introduce the relationship between yards and feet twice, you guys would all tell me there's 3 feet in 1 yard, 3 feet in 1 yard. Okay, and the reason I'm doing this according to the method we've been talking about is, again, I would put that first term over 1. So now my units of yard to the second power, I need 2 of them to cancel. I'm left with units of feet twice in the numerator, so that's feet squared. Yeah. So that's it. You know, and we have just belabored this problem. Okay. So of course our units look great. We have units of feet squared, and we just pull out the numbers and multiply them together. Okay. So nothing necessarily tricky. If you want units to the second power to cancel, you have to have 2 of those units for them to cancel. That's it. Totally it. So on the previous thing, how I worked it, I had the 1 yard squared as the first term, and then I had this quantity twice. Okay, 3 feet over 1 yard, 3 feet over 1 yard. Of course, we could group those 2 quantities and basically take them to the second power. That's fine, but if you do that, remember the, is it PEMDAS? Okay. Okay. Remember that, and I think this would fall under that rule, that square actually has to come in and be applied to the numbers and the units. So that's just to say, if you have a quantity like this, 3 feet over 1 yard, and you have the whole thing squared, it's human nature to forget that this square applies to the number and the units. Okay. All right. So that was area, length times width. But in chemistry or physical science, we're mostly likely, we're not as worried about area as we are volume. So volume is length times width times height, right, of a cube. Yeah. So let's look at what that looks like. So this is something that we can kind of look at with regard to volume. Let's just say that, again, we have a humongous Rubik's Cube. It's 1 yard by 1 yard by 1 yard. Wouldn't that be? Okay. And then each one of those units would be then what? A foot, square foot. So this is 1 yard cubed. It's 1 yard. And each layer is what, 9? 9 units, and we have 3 layers. So 9 times 3. I bet there's 27 of those little boxes. Cool. So 27 is actually, if you take 3 times 3, you get 9. 9 times 3, you get 27. So 27 actually is 3 raised to the 3rd power. This is how that works. If you're like me, I need a calculator to do those. Okay. So it's starting to kind of look like this. If we wanted to go, this is put another way. I can't remember if I work this or not in my next slide. If you wanted to convert from 1 cubic yard, 1 yard raised to the 3rd power, by golly, in order to cancel 3 units of yards, you would have to have 3 units of yards down here. And that's exactly what we have right here. Puts 1s there and put 3 feet up here. And voila, our units of 3 yards cancel with these 3 down here, and we have feet times itself 3 times, which is feet raised to the 3rd power. So I know I kind of have it written 3 times, or more than 3 times, an assortment of ways. This is one way to think of it. I really like this way, and I don't like this way so much, even though they're all the same thing. I think I lose a little bit of information. It's easy for me to make a mistake, 3 raised to the 3rd power. 3 raised to the 3rd power might not be so bad, but 2.54 raised to the 3rd power, I don't know. Need a calculator. Okay. So that's kind of what we're looking at with regard to volume. One of the things in math, which there's a lot of awesome things, fun things in math, a very important thing is if you do the same thing to both sides of the equation, then you haven't screwed it up at all. So if we apply a cube to both sides of the equation, then we still have an equality. So 1 yard raised to the 3rd power is equal to quantity 3 feet raised to the 3rd power. Again, the only, there's always that issue to make sure that you apply the cube into the number and the units. All right, so let's work a problem. A little different than what we were working. So this is within the English, no metric here. This is both English units of length here. We have inches cubed, and we want to get to cubic feet. Feet raised to the 3rd power. That shouldn't be too bad. Because, so what's the relationship between a foot and an inch?
Do we always have to start with an equivalency?
You always use an equivalency in your problem. Do you have to start with it? Probably it's a good place to start, yeah. As long as you work your problem using the factor label method, I don't really, I've seen students kind of have different.
Well, we need like a reference sheet on our tests, like are there gonna be ones that we don't know what?
If
Like
there's,
I know we have to memorize inches and centimeters.
right.
But I don't.
Yeah,
I have
if
no
there's like a
idea.
grams and pounds, I would give that to you in the problem. I don't give you like a reference sheet for
But
this
just-
test, but I
You
would
would
give it
tell
to
us what the
Yeah, in the
equivalent
problem.
statement is.
you. Yep. Yep, for
So I
sure.
don't know very many. Like I don't know. We didn't really go over that in my high school. We didn't really talk about the equivalency statements.
Oh, okay,
Like,
but like the
How
metric.
much? Yeah. We didn't really talk about that stuff. We never
Bless you.
learned it.
Google's got that converter on it.
That's what I was doing. It didn't give us it. It didn't give us the
Our, the
equivalency
Google,
statement.
yeah.
So like I talked to like how many of this is in this, and then
It doesn't give you the answer, it just gives you the, basically.
it tells you like it just gives you the equivalent.
It'll convert, like if you, I don't know if you guys have smartphones, but just in your smartphone, if you say convert 22.0 inches cubed to feet cubed, it will spit you back the correct answer. No kidding. I dare you. Yeah.
I didn't do that. I just typed in on Google like how many ones that I didn't know. So like how many milliliters or a liter or whatever, just
Uh-huh.
the stuff that was on the homework.
Yeah, but hopefully you still went ahead and wrote it out how
Yeah.
you convert.
Yeah.
Yeah.
And I just did it for the first part because I didn't know what the equivalency statement was.
Mhm.
But after I got the equivalency statement, then I wrote it.
Okay. Very good. Okay, so the first term is going to be that 22.0 inches cubed over 1. I would put it over 1. And you're going to see actually on this one slide kind of an assortment of ways. My favorite way I think I have first here. This isn't my favorite way. I would probably take 1 foot over 12 inches 3 times. So then I wouldn't get confused with my cubing my 12, basically.
So like you're saying write out 1 foot over 12, 1 foot over 12.
Mm-hmm. That's what I probably would do. Totally. So I've gone ahead and shown you the answer here. So this one might be one you want to kind of play around with. But what you'll end up with is in the top you'll have 22.0 and the bottom you'll have 12 times 12 times 12. So how come I have 3 sig figs? Does that seem right?
Yeah,
Okay.
because the 1 foot to 12 inches, those are exact, so those don't count. But then the 22.0, the 0 is where this uncertainty begins.
Yep.
So it's considered 2.
There's 3 sig figs, that's right. Very good. And this is not a significant figure here. Any questions about that? So that's it. That's converting cubic inches to cubic feet. All right, let's do another one. All right, here's another one. Again with the inches cubed, but instead of feet cubed, we're going to go to liters, which means that we're going to go, and those are volumes, right? Cubic inches to liters. And we will have to do a little bit of English to metric there. This one, strategy-wise, it looks something like this. What do we know with regard to linking units of English inches to metric centimeters?
1 inch is equal to 2.4.
Yeah, exactly. 1 inch is equal to 2.54 centimeters. And that's an exact relationship between inches and centimeters. Now, it may not be totally obvious that that's my first stop, but the reason I'm going to go from inches cubed to centimeters cubed is because if I'm at centimeters cubed, I'm pretty getting close to liters, centimeters cubed to liters. Now, I can't go directly, but what's the relationship between centimeters cubed and milliliters? You guys remember, that's one you have to memorize too. What's that relationship? It's 1 to 1, exactly. 1 centimeter cubed is equal to 1 cute little milliliter. And that's exact. And then if you look at the original problem, I was supposed to go from inches cubed to liters, so I'm not quite there. One last thing. What's the relationship between milliliters and liters?
3 zeros, 0.0000.
It is 30. I think of it as, let's see, how would that go? You could say 1 liter is equal, wait. I usually say 1 liter is equal to 1,000 milliliters.
That's what I was gonna say.
Instead of 1 milliliter is equal to 0.001 liters.
10 plus
Yeah, either one. Yep, that's the one I usually go with. It's 3. Okay. So here we go. The first term is the thing I want to convert. It's that 25.0 inches cubed over 1. Then my next stop is centimeters cubed. So I want my inches, my 3 units of inches to cancel. Looks like I would probably, again, write this ratio 3 times. 2.5 centimeters over 1 inch. 2.5 centimeters over 1 inch. 2.5 centimeters over 1 inch. And then I can see my 3 inches would cancel. I'll be left with centimeters 3 times, which is centimeters cubed. Cool. Well, I did that first step. What do you think about this step now? How am I going to get from centimeters cubed to milliliters?
You do 1 centimeter on the bottom.
1 centimeter cubed on the bottom and 1 milliliter on the top.
And
Yep,
then you cube.
that's it. Very good. And then I'm almost done. Then I need to use this relationship to get from, so what's canceled so far? My inches cubed have canceled, my centimeters cubed have canceled. I have milliliters, so what's my last term?
1 liter on the top, over 1,000 milliliters.
Yep, 1 liter on top over 1,000 milliliters, perfect.
And we're only, for the centimeters and the milliliters, we're only cubing the centimeters, right?
Right. Yep. JC asked, so here, we're only cubing the centimeters, and this is just plain old milliliters. So, let's see. Is there any uncertainty in 25.0?
Yes, the 0.
Yeah, yep, it starts at the 0, very good. So how many sig figs there?
3.
Yep. Is there any uncertainty in the centimeter inch thing?
It's exact.
That's exact. How about the milliliter centimeter thing? Exact also. How about the liter milliliter thing? Okay, so the only thing I have driving out around is this first term right here, which is 3. So on my calculator, I'm going to take 25.0 times 2.54 times 2.54 times 2.54 divided by 1,000. Round to 3 significant figures. Is this what you get? 0.410. That's 0.410 is the number, and then of course the units we have left are liters.
Oh, yeah, 14.
So on your exam for Thursday, the last part will be the fun part. It'll be the problems that you need to do for your test. And each of the problems are worth maybe 4 points or whatever. And if you round correctly, that's 1 whole point right there. So you want to make sure you round correctly.
I didn't get that.
You didn't get that?
Okay, so
How did you do
maybe
it?
I'm missing the 25.0 inches. centimeters cubed, okay, hold on, let me do it again.
How are we doing for calculators too? I know some of you guys had like scientific's what you need to have, but programmable. So programmable won't work on the test. What's that?
What's a programmable?
Like a programmable would be like, that's not programmable. It has a PRGM key. I think that one's programmable. PRGM. So that one won't work. I will bring some calculators though on Thursday.
You said we could get those little ones at the Dollar Tree, right?
You can still get them at the Dollar Tree, yeah. So if you have any questions, let me know. And also, like I said, bring some, because I don't want you to have to like do a longhand. You can't do it on your phone. So, oh, that one works. Yeah, hey. It's a nice calculator. Where's your scientific note? Oh, your EXP key. Perfect. Yeah, he's got 2 calculators. Okay. Assignment slide. Let's take a look at these right quick. Dun, 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 dun. Yay. Okay, so these kind of look like the ones you guys just handed in, right? Except now it's not just one, but these are squared. Oh, squared and then cubed. So I went ahead and reminded you, FL of course means factor label, so you have to use the factor label method. I know the instructions say put the number in the blank, but those instructions are what we're going with. You have to show all your work using the factor label method. And then for this first one, I kind of got you started. We're going from kilometers squared to meters squared. So you get an equivalency of what they are just in one dimension. So 1 kilometer is exactly equal to 1,000 meters. And then you go ahead and work it like we've been working. It's all about the units. It's all about the base. Okay, so this one's kind of similar. We have this one volume. Volume is length raised to the 3rd power, so this is meters cubed or cubic meters. We have that one volume, and you're supposed to get it into these other metric volumes. So I went ahead and kind of showed you for the first one. You're going to go from meters cubed to kilometers cubed. So 1 kilometer is exactly 1,000 meters. So this first term is the thing to convert. That's that. And then these 3 terms right here are getting my meters gone and leaving with kilometers. So that's that one. So that's those 2. And then this one is a density problem. And we talked about density. You guys did density in the lab. For density, all you got to do is isolate an object and get the mass and the volume and do a division, mass divided by volume. So this is a density problem. The problem is that mass is given in pounds and volume's given in inches cubed. So notice that what is the density in grams per cubic centimeter? So this is a case where instead of pounds on the top, you want grams, and instead of inches cubed in the bottom, you want centimeters cubed. So there's a couple of ways to work this. I would probably just leave the raw numbers up, the pounds and inches cubed, and then I would probably go after my units. Now you guys asked on a test, would I expect you guys to know this equality in blue up there? 1 pound is approximately equal to 453.6 grams. No, I would give that to you. Would I expect you to know the other one? Yeah.
Well, yeah.
Yep. So then my hint, and I'll go ahead and put this out as a PDF under, I'll tweet it out, this document. So my hint then looks something like this. You can kind of do it in what I say 3 terms, where the first term is the raw data. You got the pounds over inches cubed. This term right here came from my equivalency statement. This first term I was going after the pounds to get it to grams. So I want pounds to cancel, be left with units of grams. That was this one right here. This one right here is I'm going after my inches cubed. I want it to go away, so I'm actually gonna have 3 units of inches up here, and I wanna be left with units of centimeters to the third power in the denominator. That's exactly what I'll get if I go inches over centimeters, inches over centimeters, inches over centimeters 3 times. Then my inches cubed cancel, and I'm left with centimeters cubed in the bottom.
Okay, so, yeah, so you're doing like the grams number first, and then you're doing the centimeters.
Mm-hmm.
Cube number second, and then you just put them over the top of each other.
Mm-hmm. That's what I did. Now, some students might kind of get your first answer, your pounds per cubic inch, and then kind of go from there. So either way. Sometimes to work physical science problems, there's more than one way to kind of put the steps together. But we should all meet on the other end. Okay? Any questions about that? Well, that's how far I wanted to get. Now, we do have a couple of kind of factor label problems to work on Wednesday, kind of new problems that I'll introduce you to. That'll be Wednesday, and then your test on Thursday.
Does 105 just have just that problem, or is it like A, B?
Just that problem. Do you want more?
No, I was